My name is Jane108 and today we're going to study magic fingers. This technique is going to save you from doing 2 years of rote learning. When we went through school and we had to learn our times table, like 3 times table, 4 up to 9, it often took 2 years at school. By learning this system with a visual contact with our fingers, we're going to do rapid mental calculation. So today we're going to do 4 topics for magic fingers. We're going to look at our 9 times table using single digits, like what's 9 times 4? We're going to bend one finger and get the answer. Then we're going to do 9 times 2-digit numbers. For example, what would be 9 times 38? There's another system where we do a V shape. And then the main topic today is called magic fingers, where this is where you save 2 years of rote learning. We're going to multiply all our numbers from 6, 7, 8 and 9 by just joining our fingers and getting amazing results. That's the main part of the lesson today. And then while we're here, we want to look at all our teen numbers. Like, how did the Arabs 500 years ago multiply 12 times 13, 16 times 18, just by using their fingers? So this is an extremely special and unique method. So I'm going to give you an outline we'll start off with our 2 times table. So we all know our 2 times table. 2 times 4 is 8. Every child can learn that as they're climbing up the steps. They go 2, 4, 6, 8. So we'll tick that. We know our 2 times. We also know, most people know their 3 times. 3, 6, 9, 12. But believe it or not, this is actually one of the most difficult ones. In the Rudolf Steiner schools, the children do kinesthetic learning. They learn their 3 times table going 3, 6, 9, 12. They keep doing this kind of dance. But I found over the years when I tutor students after school, they still couldn't remember their 3 times table. So there's actually no known method how to do 3 times table. You'll be surprised. So we'll just put a question mark around the 3 times table. At the moment, I believe we still have to do memorization of the tables. So we'll put that aside. When we get to 4 times table, 4 times table is easy because it's actually made up of 2 times 2. So when we say, what's 4 times 6? What's 4 times 6? Think of 4 as 2 times 2. So it's really 2 times 2 times 6. And the name that I give for 4 times is called double double. So I'm going to apply double double to the 6 because it's 4 times 6. So double 6 is 12. We've done this one. Then we say, well, what's double 12 again? Is 24. So it's easier to multiply by 2 than it is by 4. So that's the short little trick for 4 times. So we know our 2 times table. 3 times has to be memorized. 4 times table or double double, we know that. Then we get to our 5 times table, and everyone, any child you talk to, do you know your 5 times table? And they quickly go 5, 10, 15, 20, 25, 30. So we have no problem with the 5 times table. Where it gets a bit more tricky is learning our 6 times, 7 times, 8 times, and 9 times. So what Magic Fingers is going to give us is it's going to give us the ability to use a tactile relationship with our fingers to learn from another part of the brain the mathematics of multiplication. So this is revolutionary. This is not what we call Vedic maths. Vedic maths is using sutras that we're going to discuss later on. This is part of the 108 Academy. It's a speed maths and it's using our fingers. So this has not been taught anywhere. So we're very proud to introduce a whole new system of mathematics. Today we're going to multiply using our 9 times table by working with the back of our hands. So this is 9 times single digits, and we're going to do an example called 9 times 4. So when we look at the back of our hands, we have to allocate a number for every finger. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we multiply 9 times 4, we have to bend the 4th finger from the left. 1, 2, 3, 4. So when we bend the 4th finger, that is the answer. It may look unusual, but you're looking at the answer to 9 times 4. So from this point, we allocate the digits to the left of the bend as 10 points. So we've got 10, 20, 30. So the answer is 30 something. To get the remainder, the last digit, we need to not count the bend that remains silent or invisible, and we only look at the amount of digits to the right of the bend. So we've got 1, 2, 3, 4, 5, 6. So the answer is 36. Some students don't like looking at the back of their hands. They want to do it by looking at the palm of their hands. So you could look at the palm of your hands and go 1, 2, 3, 4, bend the fourth finger and go 3, 6. That's probably an easier way, but I prefer myself to use the back of the hands. So let's do one more example. We're going to multiply 9 times 7. So using the back of the hands, we count from the left. We go 1, 2, 3, 4, 5, 6, 7. I bend the 7th finger, and straight away you can see that to the left of the bend, how many units of 10 do we have? We've got 6. And how many single digit unit points do we have to the right? We have 3. So the answer is 63. Or if you wanted to do it with the palm of your hands, you go 1, 2, 3, 4, 5, 6. I've got 6 there because I've bent the 7 and I've got 3 left over. So this is perhaps the most easiest example we have in all of the speed maths that we're doing. We're going to do the 9 times table, but multiplying any 2-digit number like 35, 49. So 2-digit numbers multiplied by 9 can be done again by applying a V shape to our fingers and one bend. So I'll give you an example. We're going to multiply 9 times 38. And what we do is we look at the first digit of 38. The first digit is a 3. So when you look again at the back of your hands, you go 1, 2, 3. Instead of bending that finger, I'm going to make a V. And as soon as you make a V, these fingers to the left of the V are worth 100 points each. So straight away, I go 1, 2, 3, that's 300. So the answer is going to be 300 and something. So I've done the V, and you can see that there's the 1, 2, 3. I'll put the V in there. So that's 3. That's 300. But we've also got the 8. See the 8 of the 38? We're going to bend the 8th finger. So I look at the back of my hands, I go 1, 2, 3, make a V and say 300. But now I need to bend the 8th finger. So I go 3, 4, 5, 6, 7, 8. I bend the 8th finger. And now I've made a partition where between the V and the bend, how many fingers do I have between the V and the bend? I've got 4. Well, these are worth 10 points. So what's 4 times 10? So we put a bend on the 8th finger. So I'm going to put another line there, and we say there's 1, 2, 3, 4. So that's 40. So the answer so far is 340. So let's do that again. We've got 9 times 38 is 1, 2, 3, say 300. Bend the 8th finger, there's 4 there, so it's 340, and we've got 2 left over, 2 units. So the answer is 342. Just a quick note, this system is quite clever. It's not that you have to know this. This is more for students to build their memory power. When I teach this to children, I want them to learn different numerical techniques. So this is not essential that every child has to do it, but you'll be surprised that when you're in a supermarket and I might have 9 apples and they're 38 cents each, we need to multiply what's 9 times 38. So quickly I go, I make a V, bend the 8th, it's 342. So this is what I call supermarket mathematics. It has a practical value, but it's not essential, but it's good to learn. But there's certain conditions. This will only work when the first digit 3 is less than the final digit. So because 3 is less than 8, we would write it like this. We say 3 is less than 8. It wouldn't work if we reverse it. If we had 9 times 83, there's another system which we're not doing today. So one condition is the first digit 3 has to be less than the 8. And also if we had something like 9 times, say, 33, where the 2 digits are the same, there's another special case. So in these examples, in the workbook that you get with this course, we're not doing the double digits, and we have to make sure that the 3 is less than the 8. So we're going to do one more example. We're going to do one more example, 9 times 48. So we'll rub this out. So 9 times 48. So the condition is we look at the 4, because first of all 4 is less than 8, so we can apply this technique. We start from the left, we look at the back of the hands, 1, 2, 3, 4, that's the 4 of the 48, and we do a V after the 4, but straight away we say 400 because each finger is worth 100. In fact, whatever that digit is, it's always the first part of the answer, so it's 400. And now we need to bend the 8th finger here. So how many digits in between the V and the bend? We've got 1, 2, 3, so it's 432. So you can practice from the workbook. There's lots of other examples with the answers, how to do them. This chapter is my favorite chapter on magic fingers because this solves all the multiplication of 6 times, 7 times, 8 times and 9 times. Remember I said before that as we went through primary school we had to do 2 years of rote learning just to learn our 6, 7, 8 and 9 times table. We've done our 9 times table by the back of the fingers, but we haven't mastered the 6, 7 and 8. So this was found in a 100-year-old book. I have a very rare library where I found this thing called magic fingers. So it's not my technique, it's something that I popularized, and it took me around the world. I spent 3 years going around the world to America, India, and just teaching this system called magic fingers because it should have been taught to every student. So this is going to solve your 6 times, 7 times, 8 times and 9 times, but this time we're going to look at the palm of our hands. So first of all, we look at the left hand and we're going to call this 6, 7, 8, 9 and 10. In fact, you could even get a texter. Some children like to get a texter and go 6, 7, 8, 9. And you don't have to write 10 here. We all know our 10 times table, 10, 20, 30, 40. So all we really need to know is what's 6, 7, 8 and 9. So the example that we're going to do is, we'll call it 7 times 8. So 7 times 8 is, I'm going to look at my left hand for the 7 and I'm going to go 6, 7 and I can wriggle that ring finger to say I've isolated the 7. Then I look at my right hand, I go 6, 7, 8, 9, 10. Where's the 8? I go 6, 7, 8, there's the 8. So now I've isolated the 7 on my left and the 8 on the right hand, and I'm going to put them together. So there's the 7 and there's the 8, and as I join the 7 and the 8, I now have my answer for 7 times 8. This is quite a remarkable dexterous trick, and it's definitely something worth learning. So you're going to say, well, how do we get the answer for 7 times 8? By looking at the palm of my hands and joining the 7 to the 8. So there's 2 rules. The first mantra or statement you need to say to yourself is everything that is joined and below is worth 10 points. So let's do it again. There's the 7 and there's the 8. I join them and I say everything joined and below is worth 10 points. So you can see I've got 2 there and 3 below. So 2 and 3 is 5. So they're worth 10 points. So when I say joined and below, I have 50. So far the answer for 7 times 8 is 50 something. So how do we get the remainder of the answer? Okay, so then we look above the join and we say, what have we got above the join? We've got 2 units and 3 units. In this case, we don't add the 2 and the 3 because the answer is not 55. We need to multiply the excess. So there's the 2 and the 3. We say 2 times 3 is 6. So the answer is 50 below and 6 above. So the answer is 5, 6, 56. I'm going to give a few more examples. So we know that 56 equals 7 times 8. Just want you to look at that numerically. We've got 56 equals 7 times 8. Just like a quick puzzle for the younger students. Do you notice anything about this equation? We've got 5, 6 equals 7, 8. Can you see any little pattern there? And I didn't know this because when I was teaching a student, there was this 15-year-old girl, and she didn't know her 3 times table. If I said to her, what's 3 times 8, she didn't know. But every time 7 times 8 came up, a bigger one, she knew straight away 56. And I said, how come you can multiply 7 times 8 but you don't even know your 3 times table? She said, oh, there's a pattern. And I didn't know this. She said 5, 6, 7, 8. So for 7 times 8, that was 5, 6. So she recognized an answer through a pattern. And then I started telling my other students that this is called consecutive order. 5, 6, 7, 8. Consecutive means when the numbers go in natural count in order. And I thought that was the only example. So here's another little story. I was with some other students, even younger, like a 10-year-old boy, and I said, this is the only example where the natural counting numbers actually give a multiplication like 7 times 8. And they said, no, Jane, there is another one, and I couldn't see it. And this is, see if you can guess what it is. If I write, if I put 12 here, so 12 equals what? 1, 2, 3, 4. So 12 equals 3 times 4. And this was the one I didn't see. But the story is that it was a 10-year-old child that educated me. And often as we're studying mathematics and you share knowledge, the story or the moral is that often when we share knowledge, the people that you're working with often come in with little gems and gifts. So I consider the 5, 6, 7, 8 and the 1, 2, 3, 4 as little mathematical gems or trophies that have been given to me from students. I just wanted to share that. So I'm going to rub this out. We've done 7 times 8. So I just want to give 2 more examples. Let's do 9 times 8. 9 times 8. So as you know, magic fingers will successfully multiply any numbers that are involved with 6, 7, 8 and 9. So we look at the 9 and we go 6, 7, 8, 9, there's the 9, I wriggle it. And then you go to your right hand and you say, where's the 8? You go 6, 7, 8, there's the 8. Once you've isolated the 9 and the 8, you bring them together and you say, I join the 9 to the 8, and there's the answer. So we say the mantra, everything joined and below is worth 10 points. So let's see, we've got 2 there and 5 below. So what's 2 and 5 is 7, but they're worth 10 points. So far we've got 70. So 9 times 8 is 70 something. So how do we isolate the final answer? So there's the 9 times the 8. We've got a 1 above and a 2 above. We don't add the 1 and the 2. We multiply the 1 times 2 is 2. So the answer is 72. So 9 times 8 equals 72. And you notice from the previous lesson that when we're multiplying by 9, we could have done it a quicker way. So 9 times 8 was really 1, 2, 3, 4, 5, 6, 7, 8. From the back of the hands, we bend the 8th finger. We've got 7 there and 2 there. So 9 8s are 72. So that was a quicker way of doing it. And I'd like to give one more example. This would be the hardest one. This involves another step. So let's say we want to multiply 6 squared. So 6 squared, really, what does that mean? So if we had a square and we divided it into 1, 2, 3, 4, 5, 6 compartments, 1, 2, 3, 4, 5, 6 columns, and also 6 rows, we've got 1, 2, 3, 4, 5, 6. So if I add in these 6 rows, that's considered 6 squared. So we could count all the little cells and go 1, 2, 3, 4, 5, 6, 7, but that's going to take a long time. So let's use our magic fingers to multiply 6 squared, but like I said, there's an extra step. So we go back to our fingers, we look at the palm of our hands, and we go 6, 7, 8, 9, where's the 6? There's the 6, and there's the 6. So we join the 2 6s, right? And the mantra is everything joined and below is worth 10 points. But we don't have anything below the baby fingers. So we just say 1 and 1, there's 2 fingers joined, that's 20. And then we add to the 20 the multiplication of the digits above. So what have we got above? We've got 1, 2, 3, 4, 1, 2, 3, 4. So here you have to know your 4 times table. And some students, when they're still learning the times table, don't know what 4 squared is. So we know 4 squared is 16, but the other way to do 4 times 4, so 4 squared, 4 times 4 is to say double double, because 4 is really 2 times 2. So you say double 4 is 8. We've done 1, 2. We double it again, and we say double 8 is 16. So 6 squared is, there's the 20 plus the 16. So you have to know what's 20 plus 6. 20 plus 16 is 36. So 6 squared is 36 little cells in that square. So that's pretty much the essence of magic fingers. It's that you can go through all the other examples yourself, like 6 times 9 and 7. So 7 squared. So you get to the point, when you do it, it's automatic. So 7 times 7 is, I join the 2 ring fingers and I go 49. That's how quick I would expect you to be doing magic fingers once you've sort of practiced it a few times. We're continuing on with magic fingers. We've successfully learned how to use our fingers to multiply all single digits, like 7 times 8, 6 times 9. Now we're going to shift to learning our teen numbers. And I believe that every teenager needs to know how to multiply their teen numbers in their head, or at least using their fingers. And this technique I'm going to show you is actually done just by curling a couple of fingers. So it is a Moroccan method, so I'm calling it Magic Teens, but it came from a very rare book called From 1 to 0, an amazing book by an Islamic scholar called Georges Ifra, and he wrote a complete encyclopedia on the history of mathematics, like how did the Chinese use the abacus and the Amazonians use knots. Well, the Arabs use their fingers to multiply their teen numbers. So what I'm going to show you now is quite historical and rare information. I've only ever seen it in one book by Georges Ifra called The History of Numbers. And we're just going to curl a couple of fingers. We're going to do 4 examples. We're going to look at 12 times 13, 13 times 14, 15 times 15, and a bigger one called 16 times 18, because in this history of mathematics, they said that we could only multiply the teen numbers up to 15. And again, while I'm working with students, some of the students said, Jane, can we multiply the bigger teen numbers, like 16 times 18? And I said, well, this book doesn't show the examples. Let's try it. And with the students, we successfully worked out that this system, called the Moroccan method, actually multiplies all your teen numbers. So what you're just about to learn is absolutely radical, new and exciting information. And again, every child needs to learn this system. So the fun name for this is called handy maths, because we're using our hands, and as it's understood, it's finger computation. So we're learning to use a tactile relationship with our fingers, which means we can remember the knowledge easier by using our body, our fingers, and keep the teens keen to want to learn this system. So I'm going to rub all this out, and in fact it is called the Moroccan method, but I'm going to call it the curling fingers method. So let's look at our first example called 12 times 13. 12 times 13. And as we proceed to learn Vedic mathematics later on, which is called rapid mental calculation, we often have to have a base number like 10. Because we've got 10 fingers, I'm just going to put in a little circle here 10, because that's our base. So we need to understand how much is 12 more than the base. So we know that 12 is 2 more. So I'm going to put a little arrow with a 2, because 12 is 2 more than 10. And the 13 is 3. So we just put a little arrow. And that's actually called a sutra. When we raise the digit, the 3, there's little sutras called by the excess. So the 3 is the excess of 13 from the base 10. As soon as I have raised the 2 and the 3, I can already calculate my answer. Just by knowing the 2 and the 3, these are the fingers that we're going to curl. So we look at the 12 on the left hand and we say, well, 12 is 2 more than 10, so I'm going to curl 2 fingers, right? That's the 12. Then for the 13 on my other hand, I say, well, here's the 13, it's 3 more, so I've curled 3 fingers. Just by curling the 2 and the 3, I've got my answer in my head. Now that might sound remarkable to you, so let's explain how we do that. I'm going to rub out the base. For this system, the curling fingers method or Moroccan method, we give ourselves 100. We're starting off with 100. We're going to add something here and we're going to add something there. That's going to be our tens and that's going to be our units. So we look at our fingers again. We said for 12 we curl 2 fingers and for the 13 we curl 3. In this system of curling fingers, we add and multiply. That we don't even think of the numbers above, we only look at what's curled. So you think of the 2 and the 3, I add the 2 and the 3, and then I multiply the 2 and the 3, done. So we add the 2 and the 3, go 2 and 3 is 5, they're worth 10 points. So what's 5 times 10? 50. So the answer so far is 100 plus the 50, and then I said we only think of the curled fingers, 2 and the 3. We added the 2 and the 3, we done that, that's 5, 50. Now we multiply, the 2 times 3 is 6, so that's the units. So the answer is 100 plus the 50 plus the 6 gives us a total of 156. And it's good to do repetition because repetition helps us memorize formulas. So I'm going to rub this out and we're going to do the next example, 13 times 14. So this is exactly the same method. There's no carryover. We are going to do an example where there is a carryover. So let's look at 13 times 14. And if you've understood the instructions I've given you, you should be able to do this quite quickly. So we say how much is 13 above the base 10? We know it's 3. Little arrow 3. And how much is 14 above the base? Little arrow, we put a 4. So in this example, all we need to know is we curl the 3 and the 4. We add the 3 and the 4, and we multiply the 3 and the 4, and we add it all to 100. So we know that 13 is 3 above 100. So I'm going, on my left hand, I curl the 3, and the 14 is 4 above 100, so I curl the 4. So the mantra is I add the 3 and the 4, then I multiply the 3 and the 4, and that's it. So the 3 and the 4 added together is 7. That's going to give me my tens. So 7 lots of 10 is 70. So the 3 plus the 4 is 7, that's 70. And then to get the units, we go 3 times the 4. So we say we add the 3 lots of 4 is 12. We add them all together, so it's 100 plus 70 plus the 12 is 182. Okay, that's easy. This time we added a little carryover. I'm going to rub this out. How quickly can you do, say, the next one? So in this book on the history of mathematics, it said that this system only works up to 15 times 15, and we've contradicted that. Our students, 10-year-old kids, said, no, we can do all team numbers. What's the funny thing about the 15 times 15 is so you curl the 5 fingers, you go 1, 2, 3, 4, 5, but when you curl them, you end up with a fist. So the 15 is a fist, and 1, 2, 3, 4, 5 is another fist. So you have to add the 5 and the 5. So to do 15 squared, you start off with 100. In fact, you don't even need to use your 5 fingers or the fist. You just say, well, there's a 5 and there's a 5. That's the excess. You add the 5 and the 5, and then you multiply the 5 and the 5. So add 5 and 5 is 10. They're 10 points, so that's another 100. And then you say, what's 5 times 5? We all know our 5 times table. 5, 10, 15, 20, 25. There's 25. So the answer is 100 plus 100 plus 25. We get 225. Okay, so that was the limit to where we were doing 15 squared. But I need to show you just one more example because the book said you can't do more than 15 times 15. So we're going to go above that and say, yeah, we can do all of them. But we obviously don't have enough fingers to do 16 times 18. So let's work it out. 16 times 18. We can say, well, you can either underline the 6 and the 8 because they're the fingers that we're going to curl. So or you could just say, I raise the 6, I'm thinking of the 6, and I raise the 8, I'm thinking of the 8. So in this system, we start off with 100 again. We give ourselves 100 points. We want the tens and the units. So, and then we say we need to add the 6 plus the 8. These are our 10 points. So 6 plus 8 is 14 times 10. That gives us 140 points. And remember I said we've added the 6 and the 8. This time we multiply the 6 and the 8. So 6 times 8. Let's just say we don't know what it is. Do you know what system we've already covered in this chapter? It's called magic fingers. So let's say we don't know what 6 times 8 is. So we look at magic fingers, the palm of our hands. We go 6, 7, 8, 9. There's the 6 there. And where's the 8? We go 6, 7, 8. There's the 8. So when you join the 6 and the 8, we say whatever's joined and below is worth 10 points. So that's 2, 3, 4. So far we've got 40 points. And we're going to add to the 40 the multiplication of what's above. So we say there's 2 there and 4 there. 2 4s are 8. So 6 times 8 is 48. So this was a bit of revision. So we add the 48. And we say what's the sum of 100 plus 140? That's 240. And another 48 is 288. So there you go. This is an amazing little system, and all it requires is a bit of practice and you'll become a speed mathematician. We've just studied a chapter called Magic Fingers, which is merely a chapter from the first book. The first book we just looked at was called Vedic Mathematics. So the 108 Academy is producing a high visual content for many topics. So we're just releasing a prototype of what's to come. So by showing you this lesson today on Magic Fingers, just recognize that this small chapter is about 1/10 from this book. So Magic Fingers came from Vedic maths. So most of these are all the workbooks that are going around the planet at the moment. Very exciting new material. And it's very interesting to know that all these titles that I'm going to show you actually existed in the curriculum 2,500 years ago. At the time of Buddha, we had some amazing people like Confucius, Lao Tzu. We had the Greek and the Macedonian Empire. So when I was a student at school, for example, in the 1970s, everything that I learned in the maths textbooks actually had its ancestry or heritage back to ancient Greece and Macedonia. And as the thousands of years went by, it was always taught, and it created this modern technology. But something happened 100 years ago where some of the curriculum makers took out all this knowledge. So Jane 108 is actually putting back into the curriculum exactly what was originally there. So I'll show you the titles. We've done Vedic mathematics, and this is called Speed Maths, Rapid Mental Calculation, and it's a tribute to an Indian master called Bharati Krishna Tirthaji, who put all this together in about the 1950s, 16 sutras. So we're going to learn the 16 sutras next. There's 2 books that come for 5 to 8 year olds. Originally we were calling them Star Kids, like Star Children, but we're currently running with the title Genius Mind because we want every child to join the dots of these magic squares and create atomic structure. And what we're doing is turning numbers into art. And again, for 5 to 8 year olds, called Genius Mind, the children are looking at the journey of the 3, 4, 5, 6. So the 3 is a triangle, 4 is a square, and then they might examine, well, a square is really a cube, and then the 5 is a pentagon, and the 6 is a hexagon. So this is a journey with numbers from 3 to 4 to 5 to 6. This is a great introduction. It's not just for 5 to 8 year olds, it's for any student. And then my favorite topic is called the divine proportion, the Fibonacci sequence. The fabulous Fibonacci numbers is found in the mathematics of flowers, it's in the human body, it's in the distances of the planets from the sun. So as we go through this knowledge, we're very excited to release this body of knowledge where we look at the Nautilus shell mathematics. Complementary to the golden ratio, also known as the divine proportion, is that this ratio 1 is to 1.618, which is basically the mathematics of when we bend our elbow, if this unit is 1, the longer distance is 1.618. But that ratio, called the golden ratio, is also in what we call the 5 platonic solids. Again, this is the knowledge that Pythagoras and the ancient Greek and Macedonian masters transmitted to this technology to give us satellite technology. Without this amazing mathematics of the divine proportion and three-dimensional geometry, we wouldn't have the scholastic knowledge and the expertise to build the free energy systems that we're building today. So this is something very experiential, where the children work with like broomsticks and joints, and they actually get embedded inside these beautiful geometries. So that's what sacred geometry is about, is remembering our connection to source. And the school, the 108 Academy, in a nutshell, is translating numbers into picture. And just like Rudolf Steiner had a spiritual education 70 years ago, we're creating another education where we're turning numbers, which is considered, numbers is like the left brain, the male, logical, analytical. We need numbers to build. But when we turn the numbers into shapes and patterns, we're accessing the right brain, cortex of the brain, which is all the high visual content, music, art, creativity, genius mind. So what we're running with the 108 Academy in a nutshell is called the art of number, translating number into symbol and sacred art. So there's a lot more to come, so stay tuned and we'll keep in touch.